So we're going to do some more on scale drawings. We started it in the last lesson, in lesson 1.7, and now we're just going to do some more with it to make sure that we're just a little more solid with it. So remember that a scale drawing represents something that is too large or too small to be drawn or built at actual size. Similarly, a scale model can be used to represent something that is too large or built too small for actual size model. The scale gives the relationship between the drawing model measure and the actual the drawing or model measure and the actual measure. So the scale, before we were calling this a scale factor. So now we're going to call it a scale because it's a real world situation. Okay, but think of it kind of that same way. So first we're going to look at a map of Missouri, and here is our scale down here. Now I'm going to make a slight change. I went through and I found it's actually closer to about 62, so 1.5 centimeters to 62 miles. So I'm going to use that instead of what is given. Okay, so if your teacher used another number, yeah, your numbers will be a little off, but it will be okay. Okay, just let them know you watched the video. So what we're going to do is we need to look, what I like to do first is look at the model. I'm going to show you two different ways to do it because I want you to see what works best for your mind. So the way that I was showing it yesterday in class, if you were in Phipps class, is that we were taking 62, that my scale factor, sorry, I have to say scale, I keep forgetting that, was 1.5 centimeters to 62 miles. And we know that if we go from the drawing to the actual, we're going to multiply, okay, so if I'm going from the drawing to the actual, I'm going to multiply by 62 over 1.5. You can't see that. So I redrew mine and rewrote what I had already done so that you could actually read it. So if you need to pause yours and also write what I've done, that's great. So remember that if I'm going from the drawing to the actual, I have to get bigger because the actual thing is going to be bigger. This is not the size of Missouri. So I know that my scale has to be more than 1. So I'm going to take my bigger number over my smaller number. So I'm going to multiply by 62 over 1.5. Okay? So that's the direction I'm going. Now, so for instance, on this problem, I'm going to take so Kansas City to St. Louis, it's already measured at 6 centimeters. So I'm going to take 6 times 62 over 1.5. Okay, pull out your calculators. And we get 6 times 62. And I got 248. Okay, so that means that 6 centimeters is 248 miles. Okay, and that's this problem right here. Now the other way I could have done it, which I saw from Miss Patterson, which I thought was a great idea too, I'm always learning, is that if we make a table. So I'm going to do this next one on a table. So we know that if we have centimeters compared to miles, we know that if I have 1.5 centimeters, I have 62 miles. Okay, so all I'm doing is I'm taking my two different things for my scale. So now I want to go from Joplin to Springfield. So I want to go from Joplin to Springfield, and we found out that that's 1.7 centimeters. So I have 1.7 centimeters. Now is it going to get bigger? Yeah, because it's not 1.7 centimeters to Springfield. So we know that if I go this direction, okay, from the drawing to the actual, I'm going to multiply by 62 over 1.5. Okay, so I'm going to take 1.7 times 62 divided by 1.5. So 1.7 times 62. So I'm going to take on my calculator. Yes, mine looks a little different than yours. Don't worry about that. But I take 1.7 times 62 equals, and then I go divide it by 1.5, and I get that this is 70.26. Since we're approximating, we're going to say approximately 70.3 miles. Okay, that's the miles. So 70.3 miles. Okay, so what I'd like you to do now is I'd like you to try either using my ratio or plugging it into the table. So I'd like you to try this one on your own, going from Kirksville to Columbia. And notice that it's going to be 2.4 centimeters on the map. So what would it be in real life from Kirksville to Columbia? And again, you can use the ratio going from drawing to actual, so 62 over 1.5, or you can plug it into the table. So pause now and try it on your own. Thank you. So I multiplied mine times the ratio and got 99.2. But I would do the same thing here. It's just that you can see I'm going from centimeters to miles. So I'd get 99.2 miles is my answer. Okay, good. I hope you got that one right also. So Remy used the scale of 1 centimeter to 5 centimeters to create a scale drawing of a basketball court. The width of his drawing was 3 centimeters. He decided that he needed a larger drawing and wants to redraw it with a new scale of 1 centimeter to 2.5. What would the new length and width of the drawing be? We only know a width. Okay, so what we're going to do here is we actually have to find the real one, the actual one, first. Then we're going to go back and tell what the scale drawing would be. So if I'm using the scale of 1 centimeter, okay, so I'm going to do it both ways again so you can decide 1 centimeter to 5 meters, okay? If I put it in the table, here's my drawing, here's my actual. I have 1 centimeter to 5 meters. Whoops, so this is centimeters, and this is meters. So if I'm going to go from here to here, what did I do? I multiplied times 5. So if I have 3 centimeters, I'm going to multiply times 5. And if I'm going from drawing to actual, okay, I'm going to multiply by 5 over 1 because it has to get bigger. So I get a 15. So 15 meters is the new court. Okay, so this is the new one. Now what we have to do, and this is where the table is awesome, and I would recommend the table, is that now it says, well, if we have 15 meters, okay, we want to change this. We want to find out what would it be if I'm using this scale factor. So now I'm going to draw a different table. I'm not going to do that. We're going to draw a different table, and we're going to say we have centimeters, and we have meters. So this is my drawing. This is my actual. Okay, and I have 1 centimeter to 2.5 meters. But this time, I start with the real basketball court. What's my actual? That's 15 meters. Okay, and now I want to go this direction. So how long is my drawing going to be? How long is that length going to be? So I'm going to go back. So before, when I go this direction, it's going to get larger. And I would multiply by the 2.5. But if I'm going to get smaller, I don't multiply by it. Okay, I would multiply by its reciprocal. Okay, so going back to what I was showing you before, if I have 1 centimeter over 2.5 meters, if I go from the drawing to the actual, I'm going to multiply by 2.5 over 1. If I go from the actual to the drawing, okay, I'm going to do the reciprocal. I'm going to multiply by 1 over 2.5. That's what's going to happen here. I'm going to multiply by 1 over 2.5. Okay, so we're going to take our calculators and take 15 times 1, divide it by 2.5, and we get 6 centimeters. Okay, pause and make sure you have all that written down. Okay, so let's go to the next page. Use a scale drawing to find the actual dimensions of each room, then find the actual area of each room. Okay, so one of the things that you need to understand is that each one of these, okay, is a centimeter. So each one of these is a centimeter. Okay, so we're going to count, and we're going to look at the master bedroom. And it says actual length and width. Who knows which one's length and width? It doesn't really matter, okay? I usually tend to take the longer one as the length, but this could also be the length. It honestly does not matter, okay? So I'm going to start that this is my length, and that's 1, 2, 3, 4, 5, okay? So if I'm making a table, I know that if I have centimeters and I have feet, so I'm going to use my scale of 2 centimeters to 5 feet. I have 1, 2, 3, 4, 5, so I'm going to have 5 centimeters, and I want to go bigger, because this is my drawing. I want to go to my actual. This is my drawing, and I want to go to my actual. Then I'm going to multiply by the actual, okay, 5 over 2. Okay, so I'm going to take 5 times 5 over 2. That'd be 25 over 2, because remember, this is just a fraction over 1, that whole number. So I get 25 over 2, which is 12 and 1/2 feet. Whoops, wrote a little too big there. That's the actual length. Now I'm going to do the same thing with the width. So I have 1, 2, 3, 4. So I'm going to take 4, and again, if you want to put it in your table, and I'm going to multiply by this 5 over 2. I'm going to multiply because I'm going this direction. So I get 20 over 2, which is 10 feet. Now I want to find the area of the actual room. Remember that to find area, you take length times width. So I'm going to take 12.5, because that's the same as 1/2, times 10. Okay? You can do it on your calculators just to let you know. Whenever you're multiplying by 10, then you can just move the decimal point. So when you multiply by 10, you can just move the decimal point. Or you could have used your calculator. Either way, you're going to get 125 feet squared, because remember, area is always a square. How many? And this actually shows it. Look, 1, 2, 3, 4, 5 squares. How many squares? So it's square inches. Okay, let's look at bedroom number 2 now, and we're going to do the same thing. Okay, it's getting bigger. We're going to use that same ratio of 5/2. So let's count the sides. 1, 2, 3, 4. So I'm going to take 4 times 5/2. Okay, which is 4 times 5, 20 over 2, which is equal to 10. Does that sound familiar? We already used it. So that's 10 feet. Okay, now let's do the other side. 1, 2, 3, 4. So we're going to take, oh wait, hello. We're doing the same thing we just did. This is a square room. So we're going to get that same thing. So we have 10. We've done it 2 other times. We don't need to show everything. We got this. Now to find the area, we're going to take the length times the width. So area is equal to length times width. So that's 10 times 10, or 100. And because it's area, it's feet squared. Okay, good. Last one we're going to look at is about a park. Okay, so we always read the problem first. The park closest to Sahara's desert is the shape of a square. That's going to be important, because remember, a square, all the sides are equal. Okay, Zara is looking at a map of the park that has a scale of 3 inches to 200 feet. 3 inches to 200 feet. Okay, and then it says on the map each side of the park is 6 inches long. Okay, each side, now we know it's not the actual, that's the map. That's the map, is 6 inches long. Okay, so that's the information we're going to use. Again, we have a couple options on how we can approach this. One great way is to look at a table. Okay, so here we go. I have inches and I have feet. I like to also put up, this is the actual, this is the drawing or the map. I'm going to put map here since it is a map. It's an actual space, not an object. Okay, so I have 3 inches to 200 feet. Let's see what they're telling us. So now it says the distance from Zaira's office to the park is 500 feet. So is that actual or is that the drawing? 500 feet. Well, it's in feet, so it's 500. Okay? So if I go from map to actual, so if I go from map to actual, can you see me up here? I'm writing up here. If I go this direction, notice it's going to get bigger. So I would multiply times. So if I go this way, I'd multiply times 200 over 3, because these are my only 2 options. It's either going to be 3 over 200 or 200 over 3. Well, the actual park is going to be bigger, so I'm going to multiply by 200 over 3. So that's what I would do if I'm going from map to actual. But look, I'm going from the actual park back the other way. Okay, so this way I go 200 over 3. What am I going to multiply back going over this way? Exactly. Hopefully you said 3 over 200. That's what you're going to multiply by. So you're going to take this distance of 500 and you're going to multiply times 3 over 200. Okay, you can take out your calculator and figure out what that would be. And did you get 7.5? 7.5 what? That's 7.5 inches. So 7.5 inches. So that's the reason I love this table, is because then you're just kind of filling it in, and I'll give you a clue. We're going to be using tables a lot in the next 2 units, most of the year. So get used to those tables. They make everything a little simpler. Now let's look at B. And on B it says Zara runs around the perimeter of the park once. Perimeter. What are we going to do there? That's right, we're going to add all sides. So we have to find a side first, okay? What distance did she run? Because first we're going to find a distance, and then we're going to take all of it, and we're going to have it 4 times. So we're going to come up with the perimeter. So here we go. If only we knew the side of one of these. Aha! We know what the map is 6 inches, okay? So I'm going to make another table because I've run out of space here, and I'm going to have inches, and I'm going to have feet, okay? And remember, this is my actual. That just helps my mind. If it helps yours, write it down. If not, that's fine. So what we know is that our scale is 3 inches to 200 feet. And now we know the map, which is in inches. I know the map. So now I'm going to go this way. So is it going to be bigger or smaller than 6? Of course, it's going to be bigger. Okay, we're not going to have a map that's less than 6 for feet. So we're going to go this direction, right? We're going to multiply. So what am I going to multiply by? I'm going to multiply by 200 over 3, because that's my scale. So I'm going to multiply by 200 over 3. Okay, so I'm taking 6 times 200 over 3. Okay, and did you get 400? So it's going to be, this answer right here is 400 feet. Now, that's this answer, but what were they asking for? Because 400 is just one side. How am I going to find the perimeter? Think about that. How am I going to find the perimeter if one side is 400? Now, some of you said that you're going to take 400 and add it up. You are right. Yay! Nice job. Okay? Some of you said, hey, I have 4 sides. Can't I just take 4 times 400? Yay! You are right. See? Go with what your mind notices. Pick one of them. You don't need to do both, because either way, I'm going to get 1,600 feet. And it's a perimeter, and all I did was find the feet. It's not feet squared, it's just feet. Okay? Now, Zara, for some reason, wants a new map. And this time, Zara is going to use this scale. Okay? So we had to find out all this other information. We're going to now take this information, okay, and we're going to go backwards. Let's make another table. I'm liking these tables a lot. Thank you, Miss Patterson. So I have inches and I have feet. This again is my actual one. This is my map or my drawing. Okay, this time I have 1 inch. That's a map, not a may. Map, sorry. So I have 1 inch to 100 feet. Okay, so if I go this direction, I'm going to multiply by 100. So it says, what would be the length of each side of the map? Now we need to find the map. Okay, I need room to work, so I'm going to erase that. But I'm going this direction. So if I need to find the side of the map, I'm looking for this. Do I know the side of the park? One of the sides? Yes, we just found it. Yay us, we just found that. That's right up here. So I'm going to start at 400, but look, I'm going the opposite direction. Opposite direction. So what am I going to do? So if I go this way, I multiply by 100 over 1. But if I go this way, I multiply by 1 over 100. So I'm going to take 400, because I'm going this direction, and I'm going to multiply by 1 over 100. Okay, you want to see a really cool thing? I love to do this. When I'm multiplying here, okay, that would give me 400 over 100. This is the fun part. Look, I get to slash out zeros. Woohoo! Yep. I find fun in lots of things, don't I? Hey, I warned you, I'm weird. Okay, so what's 4? 4 inches. 4 inches is the map. That's what the new side would have to be in the map. Okay? Good. Let's look at your homework. Okay, so now what your homework is going to be is you're going to do the scale and a set of an architectural drawing is 1/2 inch to 1.5 feet. Okay, find the length of each part of the house. Now look, it actually sets it up for you, doesn't it? It sets up the drawing and the actual. This would be the inches, wouldn't it? Inches. And this would be the feet. So if you want to, just kind of make your table a little bit bigger and say, I have 1/2 inch here, or you can write that as 0.5, and I have 1.5 feet, right? Do you see that? They already kind of set up the table for us. So if I'm going to go from here to here, what am I going to multiply by? It's getting bigger. So write that scale, okay? Write that scale. I'm just going to change this to 0.5 so I'm not confusing you. So this would be 0.5. I changed 1/2 to 0.5. So I'm going this direction. What am I going to multiply by? If you're not sure, look back at the notes. So on this one, I'm going this direction. So what am I going to multiply by? On this one, I'm going this direction. What am I going to multiply by? They're going to be reciprocals, that much I know. So you figure out this one. This one's going to be the reciprocal. Okay, good. Do those. You would like the architect to make you a new set of blueprints with a scale of 1 inch to 4 inch. The bedroom has a drawing length of 6 inches. Hello? Put it back up in your table here and find out what that new side would be. But this time, okay, and you might want to actually do another table, plugging in your new information, okay, plugging in your new information and then going. Okay, if you're not sure of the information, look back at the notes. Number 6 is part of a city building refurbishment. Architects have constructed a scale factor for the model. The scale of the model is 2 inches to 9 feet. Okay, make yourself a table. Plug in what you know. Plug in what you know. Find the other one. Same thing here. This doesn't take too much effort. Just make that little table and go. And it's going to give you different things. So here it tells you that it's 7.5 inches tall. Do you think the courthouse is really 7.5 inches tall? No. So that's going to come over on this side. Okay? So just keep all of these in mind. Draw a little T-chart right here and fill in the inches and the feet. And you're going to do great. Okay? Next page. More scale drawings. Scale drawing of an automobile has this as my scale. And I know that I have 8 feet. Hello? Draw a table. Plug it in. Makes your life easier. Okay? And always remember that it has to get bigger. So if I'm going to get bigger, okay, I'm going to multiply by a number greater than 1. If I'm going to get smaller, if I'd go this direction, I would multiply by a scale that is less than 1. That is a fraction that's less than 1. Okay, same thing here. Just keep on practicing the same things over and over again. Just make sure you understand, are they asking for the actual, what is the width on the scale drawing? Okay, are they asking for the model? That means it's going to get smaller. Okay, so I didn't want you to think that I'm telling you what to do here. Okay, what is the actual length? And how far must they go in their destination? So this would be the actual distance. You're not going to drive an inch. Okay, you're not going to drive in inches, you're going to drive in miles. So this will be the actual distance. Pay attention to that, make sure which way you're going. But if you use the table, if you make the little table, it kind of helps you out as to which way you're going. The model car below was created using a scale factor of 1/2 inch to 2 feet. Find the actual dimensions using this scale. You want to design a model of a car at a different scale. The new scale you want is 1 inch to 3 feet. Okay, give your answer in fraction form if necessary. That means there might be a repeating decimal here or something weird. So just go back to that fraction. Okay, and we can talk more about that on Friday if you're not sure what they're saying. But try this problem. Okay, so you're going to have to use what you just found out for the length and height in order to find out what it would be with the new scale model. So watch for that. We get to do another one of these problems. This time our scale, 1/2 centimeter, 17 miles, is close enough. We're going to go with that one. We're not going to change it. So just follow along. It's just like the first example that I did. If you're not sure how to do it, go back and look at that. Oh, but look at this. The actual distance is 187. Ooh, you're going to have to find the drawing for the map. And number 18, you need to make a new map using this as your scale. What would be the distance from Rolla to Springfield? Okay, from Rolla to Springfield. So we don't know the distance. Where's Rolla and Springfield? Here's Rolla and Springfield. We know the map is 3.5, but now we have to use this as our scale factor. Okay? So take what we know and go the other direction. Okay, good. So my recommendation is that you actually write this, make a whole nother table here. I'm kind of liking the idea of just making a table for each one so I know which way am I going. Am I getting bigger? Am I getting smaller? What am I going to multiply by? Okay, good. So I'd like you to work on this now, and this is due tomorrow in class. So I'd like you to do these 3 pages. Scale drawing practice, then this page, and then this page. That is what is due for tomorrow in class. Thank you. Make sure you're making good choices, and if you have questions, ask me when we see each other again.